I want to focus on what you guys have done now. You came into the classroom 2 weeks ago, and I'm going to say pretty much without fail, you all told me that you really disliked the subject and you didn't really want to get engaged with it at all, okay? And from that mindset, what you actually took out of it was, well, let's throw the ball a bit. Let's play ball and let's give it a bit of a chance. And you guys have really, really impressed me by how much you've actually been so open to it. I thought I set the bar quite high for you guys. I decided I wanted to challenge you, and you all completely and utterly smashed that because you've gone on and you've done your own work, and I really hope that you guys have taken something from it. Because that was my aim at the beginning of this. I understand a lot of you guys aren't going to continue with maths, and I know that some of you are, and I really hope that it's been beneficial for you guys. But for the guys that haven't, what you've done, and this is what I said to you at the beginning, is you've taken on a challenge and you said, you know what, I don't see the long-term benefits of this. I don't see how it's going to help me towards my goal of maybe if I'm not doing maths or matric, then it's not really going to help me at all. But you've still done it. You participated in class, and that in itself, I think, is really powerful. So I hope you guys have taken something from it. We'll chat now, and I'll ask some feedback from each of you guys individually. But I want to point out here, these are the topics that you guys have done specifically by yourself as homework. So pretty much, I said to you guys yesterday that was our last official lesson that we're really going to tackle new stuff in, and I'm telling the truth. We're just going to have a quick kind of wrap up. I want to, as I said, get some feedback from you guys. But because I've got an opportunity to hold you guys here for another kind of, call it 45 minutes, half an hour before dinner, we're going to do a bit of a recap as well, so to see how much that we actually have retained for the week. So what I want to do is we're just going to touch on some of the lessons that we've actually run through from last week, really Monday, and just maybe tie a little bit of everything together, see if we can see the bigger picture between all the subjects and why specifically I chose those ones for you guys to do. So the very first one is the introduction we did in the number systems. The number systems, the point of that was to try and give you just an overview of really where this idea of maths comes from and how maths is so specifically tied to counting. If I draw two triangles like this, knew I was going to use the board, like that and like that.
Is that a triangle?
Are those, so there's one point, there's another point.
Okay.
I'm just not very good at drawing straight lines.
Okay.
Those angles add up to 180 degrees, but are the angles the same?
No.
In those, so are these triangles similar?
No.
They're not, okay? So again, what's the specific rule that we need for similar triangles?
Right triangles or trigonometry triangles are all similar.
Okay.
The ratios need to be equal.
Not entirely. I'll chat to. Okay, the ratios of the sides need to be equal. What about the angles, guys?
The angles need to
Equal
be
angles.
equal as well.
I was going to say the interior angle should also be equal.
The angles, the corresponding angles have to be equal. You're exactly right. So if this triangle was similar to that triangle, that angle would have to be the same as that angle would have to be the same as that angle, and that angle would have to be the same as that angle. The angles, the interior angles, the corresponding interior angles must be equal. Okay?
Yes.
Not too bad. We then went on and we talked about these ideas of right angle triangles. Okay, and that's when we came into specific similar triangles that were right angle. Okay, and you can draw various different versions of right angle triangles, ones that have a very small base, ones that are fairly normal, and ones that have a big base, small height. The fact of the matter is they all have 90 degrees. Are these triangles similar though?
No.
No, they're not. Okay, why they're not similar?
Because
Their angles are not corresponding.
Good. The corresponding angles are not equal. Fantastic, okay? But what happens with these triangles, when I make a bigger version of just this triangle, or a bigger version of just this triangle, or a bigger version of just this triangle, what happens is, if I know that angle here, do I know this angle?
Yes.
Do I?
Yes.
How do I know?
Because
Because it's a
because
90
the
degrees.
90 degree
So how do I work it out?
You say 90 degrees plus that angle.
Minus-
180
Uh-huh.
minus that 90 plus that angle.
Yes.
Get those?
Fantastic, and I can work out what the other angle is. So the thing with the really cool thing with these 90-degree triangles is if I know what this angle here is, I actually know what that angle there is, and I know what this angle is because it's 90 degrees. So I can work out what are the ratios of the sides for every single triangle with that angle there. And that's when we started to define these ideas of these ratios for specific, sorry about that, for specific triangles. These ratios, I cannot say this word. Help me. For specific angles here. How are we going to define these ratios for these angles to know exactly what the opposite side over the hypotenuse, the adjacent side over the hypotenuse, and the opposite over the adjacent side is for that angle? So that's when we talk about sine of an angle is equal to a specific ratio. Got it? 100%, yeah. You're gonna go wild like Giovanni. 5 points for me, WeChat. Let's go. I'm getting in the running as well. Okay, guys. So just briefly remind me then, what are the 3 ratios that we learned about?
So Katoa.
Good. Okay, and tell me what that stands for.
Sine opposite over hypotenuse.
Sine of the angle is equal to opposite over hypotenuse, and I'm going to put the angle there, and the angle there. Yeah.
Cos adjacent over hypotenuse.
Good. And?
And then tan opposite over adjacent.
Fantastic. And Shanvi's going to remind us, what does the word adjacent mean?
What does it mean?
You forgot.
It's the wait. If the hypotenuse is here,
So we're looking from the perspective of x here.
it's gonna be
This one or this one? Tell me which one I'm pointing at. That one?
that one.
Or
That's
this
one.
one? This one. That is the adjacent side. Winning! That's all good. Giovanni is just like, his soul's ended. Okay, fantastic guys. So we now know, from the perspective of this angle, we can define any triangle that has the opposite side, the angle side, and the hypotenuse, obviously. Yes. Okay, now a couple of you guys in the chapter, and I saw some questions asked on that when you guys were working through it, came across these other funny things. An idea of what? Cot?
What?
Okay.
It's called sec inclusive.
Come across these different names. The question is, what are these guys?
What's the last one?
Cosec, sorry. So we got cot, sec, and cosec. What are those guys? Can I throw a bit of a mix in there? Did anyone want to take a stab at it?
It's cot and sec together. Cosec.
I like it, okay. Not entirely. The idea with these things is Pam thinks that's really funny. Pam, do you want to take a better stab at this?
No, I don't know.
What? Okay, guys. The idea with these angles, and a lot of you said when you were working through the homework that you didn't really know what they're talking about, is they're actually nothing new. You already know exactly what this is saying, because all it's saying is, well, sine, for example, defines the ratio opposite over hypotenuse. The one that pairs up with sine is cosec. Cosec defines the ratio hypotenuse over opposite. So all cosec is it's 1 divided by sine. It's just sine flipped around. Okay, the same with cot is tan flipped around, and sec is cos flipped around. So it's just new names for the inverse of those ratios. That's why I didn't really bother to even talk about them in class, because all they are is the ones that you already know flipped over. 1 divided by it. Shani thinks that's hilarious.
Don't fight. You did it twice, yes, twice. I'm really close to you today, please.